Hello friends, continuing with the chapter of current electricity. Today we come to part 7 of the topic measurement of EMF, that is internal resistance of primary cells. Now how we measure internal resistance of primary cells is the topic today that we are to learn. Now to proceed with, first we draw circuit diagram. Circuit diagram for determining internal resistance of primary cell is as shown. AB is potentiometer wire, EAUX is the EMF of the auxiliary battery used for maintaining steady current through potentiometer wire of uniform area of cross section. MA is milliampere meter to record steady current. S is on off switch and RH is rheostat to regulate the current through potentiometer wire AB. Circuit diagram continued. C1 is primary cells whose internal resistance is to be determined. G is galvanometer for detecting null point and is connected to cell C1 through a two-way key K1 and K2. RS is the safety resistance for the safety of galvanometer connected to it through key K dash and is generally of 1000 ohm. The other end of galvanometer is connected to a sliding contact called as jockey. Now internal resistance of primary cell. Consider the portion of the circuit P, X, Y, Q and P as shown in diagram. According to Kirchhoff's voltage law, voltage equation can be written as minus I into capital R minus I into small r plus E1 is equal to 0, or we can write I into small r equal to E1 minus I into capital R, or it is equal to E1 minus V, because V is equal to I into capital R. Now from here we calculate small r, the internal resistance of the primary cell. We can write small r equal to E1 minus V by I, and we replace I by V by R, and then on simplifying we get small r is equal to capital R into E1 minus V divided by V, or we can write small r is equal to capital R into E1 by V minus 1, or we can write small r is equal to capital R into E1 by V minus 1, and finally we write internal resistance of the primary cell small r is equal to capital R into E1 by V minus 1, or we can write internal resistance of primary cell small r is equal to capital R into E1 minus V minus 1. Let us mark it as equation 1. Precautions. We have to observe certain precautions before conducting the experiment for determination of internal resistance. First precaution is ensure that EMF of auxiliary battery is more than the EMF of the primary cell. Second, all the positive terminals of primary cell and auxiliary battery be connected to one point A. 3. Keys must be closed only when observations are to be taken. Otherwise, potentiometer wire will become hot, resulting into change in its resistance. Fourth, safety resistance of 1000 ohm must be used in series with galvanometer for its safety and must be taken out while reaching near null point by closing key K dash. 5. Rheostat must be of low value of nearly 20 ohm so that slight variations cause small change in current flow. Sixth, clean all wires and terminals before making connections and all connections be tight. Seventh, press jockey gently on potentiometer wire so that its area of cross section does not change. 8. Value of R must vary from 2 to 8 ohm. Okay, so these are the precautions to be observed before starting with the experiment for measurement of internal resistance of primary cell. Now procedure, how we are to proceed for measurement of internal resistance. So look at the circuit diagram. First point is switch S is closed and steady current is maintained through potentiometer wire AB by fixing the position of rheostat and is recorded from milliampere meter. 2. Key K1 is closed and K dash remains open. Cell C1 is connected in the circuit. Sliding contact jockey is brought near end A of the potentiometer wire and direction of deflection in galvanometer is recorded. Let it be as shown, that is towards left hand side. I repeat, key K1 is closed and K dash remains open. Cell C1 is connected in the circuit. Sliding contact jockey is brought near end A of the potentiometer wire and direction of deflection in galvanometer is recorded. Let it be as shown, that is towards left hand side. Now testing the circuit continues. Third step, sliding contact jockey is brought near end B of the potentiometer wire and direction of deflection in galvanometer is recorded. It must be opposite to end A and should be as shown. If it is not opposite but in same direction as shown, then there may be two defects in the circuit. Now we are to see what are those two defects and how we detect these defects. Now two defects, what could be two defects if direction of deflection is on the same side at the end B as that at end A. Now first could be either E auxiliary is less than E1, or negative of primary cell is connected at end A with positive of auxiliary battery. Now how to identify which defect exists? If deflection at end B is less than at end A, then defect 1 exists, that is E auxiliary is less than E1 exists. And if deflection at end B is more than at end A, then defect 2 exists, that is negative of primary cell C1 is connected at end A with the positive of auxiliary battery. Now confirmation of correctness of the circuit. Correct the circuit and confirm for opposite deflection at both ends when jockey is brought near them. Now, second step, after testing the circuit, after ensuring that circuit is correct, we come to measuring EMFs of cell C1. Now, first step is cell C1 in circuit. Now close key K1 and move sliding contact gently on potentiometer wire and obtain null point. At this point, close key K dash also and again obtain null point. Let it be at J1. Record length A J1. Let it be L1. Then, according to principle of potentiometer, we have E1 is equal to KL1. Let us mark it as equation 2. Okay. Now measuring V, potential difference, terminal potential difference. When R comes into circuit, EMF no longer remains there. The terminal PD is potential difference. Okay. Now close key K2 also. Move sliding contact gently on potentiometer wire and obtain null point. At this point, close key K dash and again obtain null point. Let it be at J2. Record length A J2. Let it be L2. Then, according to principle of potentiometer, V is equal to KL2. Let us mark it as equation 3. Now, third step is comparison of E1 and V. So, dividing equations 2 and 3, we get E1 by V is equal to KL1 by KL2. Here KK cancels, so we are left with L1 by L2. So finally we have E1 by V is equal to L1 by L2. Let us mark it as equation 4. Now substituting the value of E1 by V from equation 4 in equation 1, which is small r is equal to capital R into E1 by V minus 1. So when we substitute the value of E1 by V in this equation, we get R is equal to capital R into L1 by L2 minus 1, and is the working formula for internal resistance of the cell. For different values of capital R and same steady current, values of L1 and L2 are recorded and small r, that is internal resistance of the cell, is calculated. So by taking mean of all r's, the internal resistance of the primary cell is finally calculated. So this is how we determine internal resistance of primary cell using potentiometer in laboratory. Okay. Now assignment 3.7 continued. Question number 19. For the circuit shown here, would the balancing length increase, decrease, or remain same if number 1 R1 is decreased, number 2 R2 is increased? So you solve this numerical on the basis of the text that you have learned. Thank you so much. Here we finish with the chapter of current electricity, and next time we will take up a new chapter of magnetism. Till then, goodbye. Good luck to you.